So, good morning, everyone. So, in this today, we will be definitely discuss about the theory of simple bending, or it's also another name is that theory of pure bending. And this is the second chapter of strength of material, or you can say that second unit of strength of material. So, let's move to the inside this unit. So, next slide is. Ah, okay. This is our slide. So in here, so we are going to be discuss about the bending. So let's try to be understand what is the bending. So second unit name is the bending in the beam. If a member is subjected to equal and opposite couple acting in same longitudinal plane, the member is said to be in pure bending. As simple you can understood there. This is a beam. You applied the two bending moment equal and opposite direction. You applied the moment from clockwise, a clockwise movement and anti-clockwise. This is called equal and opposite couple in the same longitudinal. This is the longitudinal plane. This one longitudinal. So, so one bending is developed in the beam that is called the pure bending. The internal stress developed in stress inside the beam. This is known as a flexural or bending stress. So definitely when you apply the equal and opposite couple, so a stress is developed in between the planes of the bending. So that stress is called the bending stress or the flexural stress. There is an intermediate surface known as the neutral surface. This surface, which you can see that this whole surface, this dot line, make a surface. You like see this. This is called this one, the intermediate one. You can see this plane, and is you just move on this side and this side as well. This whole surface is called a neutral surface. Why it is called neutral surface? Because even or even in before applying the couple or after applying the couple, there will be no stress. That's why it's called a neutral surface. So here there is no bending stress in this plane, this one, this dotted line. Okay, so this is called the neutral surface. Okay, and an axis obtained by intersection of neutral surface. You already know this is called intermediate surface is called the neutral surface. So intersection of the neutral surface and the cross section. This is called the cross section. This square is called cross section of this beam. So where this neutral surface, which is exactly located at the middle of its height, this the intersection of this middle neutral surface and cross section is called the neutral axis of the beam. Okay, this is called the neutral axis, about which bending of surface takes place. So you can say that this is a neutral axis. This is a neutral axis. You might be seen that here. You can see that, and it's about this axis bending takes place. Okay, let's move the next slide. This is okay. I would like to explain more things here. So this is the neutral axis, and this is called a vertical axis. This is a vertical axis, and this is vertical axis. We can say, and one more thing, and every time we are assuming that in this neutral surface there is no stress even after applying the couple of equal and opposite sign. And this is the neutral axis. You remember these things, so it will be helpful to you in the future also. So next come to the theory of pure bending, or we can say the theory of simple bending. When a beam having an arbitrary cross section is subjected to a transverse load, the beam will bend. In addition to bending, the other effects such as a twisting, buckling may occur. To investigate the problem, they include all combined effect of bending, twisting, buckling, could come a complicated one. So its simple meaning, if you are applying the load on the beam, there may be a twisting also, there may be a buckling also, and there is a bending also. But but the thing is that we, dear, we cannot be consider the each and every parameter why solving the problem of bending. It's become a more complicated. So thus we are so interested to investigate the bending effects alone. In order to do so, we have to put certain constraint on geometry of the beam and that manner of the loading. So we are taking some assumptions, as we know that when we are going to be produce or develop some mathematical problem, or at that case we have to be take some assumptions. While taking the assumption, we are able to solve the problem. Otherwise it's very difficult to solve the problem. We get the numerical any mathematical problems we are getting, so we have to be take some assumptions. So as long as we have to be here consider some assumptions also before proceeding ahead, before finding the equation of bending. So here some assumptions are: bending is a bending beam is initially straight, has no constant cross section area. So it must be straight. This is the first assumption. Beam must be straight. There is no bending before applying the couple. So second assumption is beam is made of homogeneous material. The beam has a longitudinal plane of symmetry. So it means the beam has the made of same materials. That would be a applicable what equation we are going to be find out. So initially beam is straight. All longitudinal filament are bent into the circular arc with common center of curvature, which is large as compared to the dimensions of the cross section. So it simply means the beam initially is straight. When you apply the load, you assume a packet of bread. You assume the packet of bread. You just when you try to be apply a couple like in this axis. So what happened? Each and every the filament this try to be come up is in this manner. So initially the center of curvature are and center of curvature. So if suppose this is my hand, if I curve this, so definitely the center of curvature is made somewhere in the space. So this is the meaning of this statement. The elastic limit is now nowhere exceed, and E is the same in tension and compression. It means material is homogeneous. Okay, the plane cross section remain plane before and after bending. The cross section, what I have explained here, this is a cross section of the beam. It must be remain the same before and after the bending. These are the assumptions. So please you remember all the assumptions. It will be help to the examination also. It's come sometime. So let's move to that ahead to understand this concept of the bending and derive the bending formula. Let us consider a beam initially unstressed, shown in the figure 1a. Now the beam is subjected to a constant bending moment. So we applied a constant bending moment here in this second figure. You might be able to see that. Then we have this R is the radius of curvature. This is R. This is called the radius of curvature. As a result of this bending, the top fiber of the beam will subjected to tension. Obviously, this is the in tension and inner fiber are in the compression. You can easily understood. Therefore the sum where between the two Between the two, there are a point at which the stress is zero. The locus of all such point is known as the neutral axis. So you all know that what is the neutral axis? This one. This is the axis of neutral axis, where no stress is existed. So the radius of curvature R then measured to this axis. For the symmetrical section, the neutral axis is axis of symmetry, but whatever section neutral axis will be always pass through the center of area or centroid. So if you take, you try to understand by this like this. So this is this is the cross section area, and this is called, so we have this neutral axis, and one is which is passing over here also. So this is also, there is no effect over there. So this is always passing through the cross-sectional area. It's meaning of this sentence. So you see this cross-section area. This is the initial beam. You can see there is a few points mentioned here: H, D, A, B, C, D. C, D is located on the, this is a neutral on this neutral surface. You see, this is a neutral surface one. And y is the location of a element which is you, the element which is you taken AB, the distance of AB here. So if you are applying a couple, a moment on that, so it's bent, suppose like this. So there you see, this is the radius of curvature, and the two end points, they are making some angle, that is a theta. Okay, let's see, let's move ahead. So in order to, then now we are going to be find out the bending equations. So in order to compute the value of bending stress developed in loaded beam, let us consider the two cross section area of the beam. So we have taken the two section, cross section HE and GF. You can see here, this is taken, we have taken this portion we have considered. Okay, so all this mentioned whatever in diagram shown, that you can see the final position of the section is still straight line. They are subtended some angle of theta degree. So consider now a fiber AB is a material at a distance y from the neutral axis. When the beam bent, this will stretch at A dash B dash. अब समझते हैं थोड़ा सा इस डायग्राम से. Initially A is like this. When you applied the bending moment, so bending here in this way. So what happened, there is a bending is developed inside in this element also. Now the AB become A dash, B dash, HG become H dash, G dash, and this element CD becomes C dash, D dash. So before beam is like this. When you apply a couple, so it's bent like this. So every filament will be bent according to that. So new positions is like this. So before, if the length of this filament is AB, A dash, which is shown in the dot line, this AB, then after applying the couple, it's become A dash, B dash. The length has been
सर
changed.
ए डैश बी डैश कहाँ से आया सर?
So after applying the couple, when you apply this M in the both side like this in a straight line, you apply the couple, it will be bent. So initially it is a straight line. It is a straight AB. When we are applying the couple, it will be bent. So the new name of AB is the A dash B dash. New A dash B dash.
Okay, sir.
And before that is HG. So new name is the H dash G dash. Like a new name of CD is C dash D dash after applying the couple. Okay, so let's move. So this is all about. So if we are considering the fiber AB, so there is a change in length, definitely. Initially it was AB, and when you applying the couple, so it's become A dash B dash. So definitely there is a change in length. So that is A dash B dash minus of AB upon AB. Because change in length is what? Change in length क्या कहलाता है? Original length upon sorry,
Original,
change in length upon original length. जो length is
original
changed.
length.
Okay, great. So original length. So this is a formula of stress. So we are going to be find the strain in the fiber AB. So strain, this is a strain in the fiber AB. So, dear, so in strain, we know that strain we can write sigma upon E. We can write strain as a sigma upon E. And
On
change
E.
in,
Yes,
yeah.
sir.
And A dash B dash we can see from here. You can see that A dash and B dash. You see. This is called the center of curvature. This is R. So AB, the distance of this point, this point you can see this point distance from here to this filament. This is called R, central one. This neutral surface is R. So we are talking about the length of this. So how can we find if we know that this angle or this is a theta and we know that this distance r plus y, this is a y, we are already assumed that this is a y. So r plus y into theta will give the length of this arc. You can find the length of arc if you have subtended angle and length of the radius. You can find, you know that. So we can we can write this like this. You can see this is how can r plus y into theta. This is the length of A dash B dash after applying the couple. You can see that this this A dash and B dash because we have this length because we have the r and plus y. So we reach here and just multiply by this angle theta. So we can find out. सिंपल आपने पढ़ा होगा पहले से भी. दिस इज इफ वी हैव आर्क like this, if angle is this theta and if we know this length, this radius r, so what will be this? How can calculate this arc का formula you know that arc is equal to what? Theta into r. This is the same thing which is happening here. So dear, so हम आगे इसको मूव करते हैं. देन हाउ टू कैलकुलेट ए बी. दिस इज द पॉइंट. How to calculate AB because we don't have AB here. So we have to define the AB. Let's see there, my dear student. So initially we can see here. Initially we know that these two AB and CD are parallel. Initially original length, because these two are in
Yes, sir.
parallel, it means AB and CD are equal. And we know that the CD is the neutral surface. There is no effect of the bending. It means after bending, it means the after applying the couple, this neutral surface CD, this neutral one, this C dash D dash will be equal to the CD and CD is equal to the AB. That's why you can say AB will be equal to R theta because that this is called R and this angle is theta. समझ में आया? You are understood that? Because you just link this. Initially AB and CD both are equal. And CD point is lie on the neutral surface, and neutral surface is surface where is no effect of the stress, no effect of the bending. It means the CD and C dash D dash both are the equal at the every time. When the CD and C dash D dash are equal and initially AB and CD are equal, so we can say So this AB will be R theta. So this come from this that concept. So we just write down here R theta and just solve it. So it's become Y upon R, and you can rewrite sigma upon Y E by R. This is equation number 1. So we can also say that the stress is proportional to the distance from the neutral axis. Let's move. Consider a arbitrary area. You have studied all these things. What now I am teaching you in our first semester engineering mechanics. You try to recall this. So consider any arbitrary cross section of the beam as shown. Now the strain on fiber at distance y. This is a neutral axis. This is called the neutral axis given by the expression. So we have just derived this relation sigma is equal to E by R into Y. So this is a one equation. If this area, strip area, what we have taken this this is a whole area, and we have taken this elementary area, and if this area this is the area of DA or del A, जो भी आपको लेना है, no problem उससे DA or del A. Then force on X strip, how much force will we act? Force निकालने के लिए, if you know that the stress on that area, you just multiply by the area on the stress, you can get the force. This is a simple formula what you have studied in the first unit. So force is equal sigma is equal to force upon A. So force is equal to sigma into A. Now just put this value here, E by R y into d theta or del theta. Okay, the total moment of the whole cross section therefore equal to. So this is the, we know that here this is the force acting on this element. And again, if you want the movement of this area against the about this neutral axis, so what we have to do, just you क्या करना है आपको, जस्ट एक बार मोमेंट लेना है, क्योंकि पूरे एरिया का लेना है तो यू हैव टू बी अप्लाई दिस सम ऑफ, आपको पूरा सम करना पड़ेगा. ये छोटे के लिए तो छोटों के लिए तो यहाँ से फोर्स निकाल लिया, देन यू हैव द नाउ द फोर्स एक्टिंग ऑन द होल एरिया. सो हाउ टू बी फाइंड द मोमेंट, द टोटल मोमेंट फॉर होल क्रॉस सेक्शनल एरिया इज इक्वल टू एम. मोमेंट मीन्स एम, ये सब आपने पढ़ा है फर्स्ट सेमेस्टर में, जस्ट ट्राई टू बी रिकॉल इट. M is equal to this force, whatever the force you have, just multiply by the distance from the neutral axis. This distance is y, so you just multiply here, so y into y square become y square, and this is force acting on the small area, and if you take the sum of that, so it's a force movement acting on the whole area. So this some symbol is come up with this concept. So this is a constant E by R, so it's come outside. Now the new relation is sum of y square d theta or del A or dA. So now you might be remember dear. So this term is called, what is this? This is the moment of area, and moment of area is called moment of inertia. Moment of area is called moment of inertia. ये आप याद रखिए, दो बार अगर एरिया का you take the moment, it's become moment of the inertia. Now let's come to the conclusion. So this term is called the is called the moment of the area or moment of inertia, and it is represented by the symbol I. So it is then sum of y square del A, it can be now replaced by the I. So this relation become m upon ER upon I, and now we can rearrange m upon I E by R. So this is the final expression, equation number 2. Then we have the equation number 1. What was the equation number 1? This was sigma upon y upon E by R. Now here the one term is common, E by R. So we can combining both equation 1 and 2 here. So it's become sigma upon y from equation number 1, m upon I from equation number 2, and e by r is common in the both equation. So now we can write sigma upon y, m upon I, e by r. This equation is called bending theory equation or flexural bending equation. So this is all about this equation. This is a very important equation as per the this unit is concerned. You might be every time you have to be remember this equation.